All right, so hello everyone, thank you for coming. I'm Daniel Fernandez. I'm a lead software engineer at Cadence Design Systems. I have a slide on my whole bio somewhere in the middle of the presentation, so we'll talk more about that later. But for now, I'd like to introduce the rest of our Cadence representatives here. So in no particular order, Kira, you want to go first?
Sure. Hi, everyone. So I'm Kira. I work on the academic network team, which is the team that provides the Cadence licenses to your university. I support all sorts of programs like student events and scholarships. Yeah, that's what I do. Thanks, David. You want to go ahead?
Certainly. I similarly am on the Cadence Academic Network, just helping to make sure that we at Cadence are partnering really well with universities and however we can help and work with you guys best.
Great.
Hey everyone, this is, can you guys hear me?
Yes.
Okay, cool. I'm Brian from our Cadence recruiting team. I recruit for our custom IC and PCB design teams. If you guys have any questions, please let us know at the end, anything related to recruiting or how to get a job at Cadence. Happy to answer questions.
Great. And I think that's everyone. So without further ado, I'll advance to the next slide. Unleash imagination. Boom. All right. So if you guys have been reading the news lately, you might have heard there is trouble afoot. Chips are in hot demand, and it's a problem. I don't know if you guys, how big this is appearing on your screen, depending on your screen resolution, but I'll read this out to you. First one is from the New York Times. You can't find a laptop or a car? Buying electronics now is rough. Be patient. Shop around and try not to break anything important. Under the first couple paragraphs say, are you tired of me yammering about computer chips and how important they are? Too bad. For a host of reasons, shortages of chips are limiting production of everything from cars to video game consoles and maybe airplanes. Several big automakers, including Ford, Volkswagen, have slowed or temporarily stopped manufacturing. Second one is from Wall Street Journal. Chips are in hot demand, and that's a problem. Surging appetite for 5G smartphones, rebounding car sales, squeeze semiconductor makers. I'm not going to read the rest of these paragraphs because it says a very similar thing. Another one from WSJ that a whole, headline piece, how car makers collided with a global chip shortage. Two more headlines. This one I think is also WSJ, White House to meet with lawmakers about chip shortage. President Biden has made supply chain problems a priority and executive order is imminent. And BBC, last one, how will Chipageddon affect you? So there's kind of a truism. You don't know what you've got until it's gone, right? We're seeing right now this global semiconductor shortage, of which Cadence is a key part in this whole semiconductor ecosystem and supply chain. And when you don't have chips, bad things happen, right? Cars right now are becoming computers on wheels. Everything from coffee makers to now we're having smart beds that can actively cool. Those also have chips, right? So you can't even sleep without having chips. And we'll talk more about this later. So I stole two slides from a talk from one of our bloggers called Paul McClelland, and he runs a popular blog called Breakfast Bites. And he ran a blog before at semiwiki.org, I believe, called EDA Graffiti. And the slides in his talk that I pulled these two out because I think it's a useful analogy, and lots of people in the EDA space like to make this analogy between chip design and making an airplane. And it's a little bit harder than making an airplane because it feels like you're assembling the airplane on the runway while it's taking off. So here's the equivalent problem. Design the Airbus A380, but you only have 12 months. And the manufacturing technology has never been used before, right? Because we're constantly changing nodes. We're going to smaller and smaller transistors, smaller and smaller lithography, new processes being implemented like optoelectronics, and so forth. And you must use tools that have only just been released and never used for a real design. So we're pushing out new software builds all the time, and put the first prototype straight into high volume production in August for the Christmas market. Everyone wants their PlayStation 3 on December 25th, right in time for Santa to arrive. And then start work on the next even bigger one, since the design will be obsolete by summer, right? This is how quickly our industry moves. And so the physics is constantly changing. It's like building on a shifting sandbar. The care-abouts also keep changing. So in the 80s, people cared about area because semiconductor manufacturing is really priced by the millimeter, right? Every single millimeter you can shave off is potentially, millions of dollars saved. And then people started to care more about timing and area. And then as mobile chips started to become more popular, smartphones and so forth, the smartphone era, people started to care more about power. And power is becoming really, really important. Obviously you don't want your battery to die. You want to have a smartphone that lasts a long time, right? But, people just said, oh, okay, this is only important for the smartphone era, but desktops, those don't, we have a wall outlet, right? Unlimited energy, right? Who cares about the power there? No, it turns out people are now starting to use low power ARM RISC cores in the data center, and there are startups doing that now, which Cadence has also invested in. And why? Because power means heat. And so now you have to spend lots of money on air conditioning, right? And your power bill goes up, and electricity is becoming more and more expensive. So now power is pervading everything. It's not just smartphones anymore. And we'll talk more about that later too. There's a short but unforgiving design cycle, market driven by consumers. So Christmas and Chinese New Year don't slip. Important to meet those deadlines. Huge scale, literally several billion active parts, right? So before electronic design automation, it's kind of in the name, people used to, prior to design automation, people would tape things out. And tape out means you actually got tape and you would go down to a floor and start making masks, taping out where your trace lines would be and where the wires would go. And you could you could memorize how many transistors were in your chip. Now there are millions and billions of transistors in a chip, right? There's no possible way you can possibly know what each transistor does. It's just impossible. You need software to make a chip now. And if you need software, Cadence is the one that you have to come to. So it's very expensive. 10 to 100 million for a typical chip, 1 billion for a state-of-the-art microprocessor. And then you have to make that money back. So you invest all this money on the front end, and the finished product is going to be sent out immediately. And if it doesn't work, it's going to be a disaster. And you have to recoup all that money, right? You invested millions of dollars and you're hoping to make millions of dollars once this rocket takes off. So that's what it's like to be in the EDA world, or the semiconductor world writ large. And so I'm going to refer you to the rest of Paul McClellan's EDA 101. It's available on YouTube. You can just Google for EDA 101, Introduction to Electronic Design Automation. These are the topics that he covers. So he talks a little bit about Moore's Law. He has a book about it called Fabless. You can buy on Amazon. And yeah, I just wanted to pull those the chip design slide out for you. Yeah, I think that's all I want to say about that. And so I like this slide. Cadence, this is our visionary slide for what we call our intelligent system design strategy. Cadence is leading the computational software convergence. And when Cadence started off, it's basically SPICE. It was like analog design, right? But then we started growing and growing and growing through acquisitions and mergers. So now we do PCBs, right? Now we do machine learning actually is embedded in some of our products to make better chip designs, right? We do packaging, we do multi-physics. We'll talk about Clarity, which is our electromagnetic solver, and Celsius, which is our thermal solver, right? So like I was talking about, power and heat go together. So If you want to build a chip, you can't have a smartphone that starts burning your consumer in their hand, right? And so I like to explain this diagram, the concentric circles, as like an autonomous vehicle, right? You start off with the design. You come to us and say, okay, I need to build a chip. Well, now what are you going to do with that chip? You're going to put it inside of a car, and you need to cool that chip down if you're running a neural net. So now we start talking about the system. Start to talk about the LiDAR. You say, okay, well, now I'm doing computer vision. I need a digital signal processing core. Can I get that? Yes, we also sell, we have a line of what we call IP cores called Tensilica. And that's something that we can provide to you as well, so that you don't have to design it all alone, all on your own. And then making this whole system intelligent and pervasive intelligence. And so that's kind of how Cadence is growing. We're growing our total addressable market because the applications are growing, right, in terms of artificial intelligence or 5G. And the number of companies making chips, they're adding their own special sauce to their chips, and they want to make a custom chip. It's no longer the case that it's now becoming more economical to actually make your own chip instead of just buying an Intel processor off the charts and trying to integrate it into your system. And so that's how Cadence has started to really take off. So what we do intelligent system design, innovating from chips to boards to intelligent systems. Cadence software, hardware, and IP enable electronic systems and semiconductor companies to create the innovative products that are transforming the way people live, work, and play. And our mission statement, because you always have to have a mission statement, we innovate technologies essential to building great products that transform lives. Okay, so I'm going to spend a little bit more time on this slide. We have, I guess, the big four are called business groups, and the subheadings are called business units. And so I'm going to highlight my business unit down here later, but we'll start off on the left, digital and sign-off. So if you are in the electrical engineering field or computer engineering field, you may recognize some of these names down here, especially if you're one of our academic partners, and you can come and request a license for some of these products. So Joules is our RTL power analysis. Genus is our RTL synthesis. So you start off with system Verilog or some high-level hardware description language that looks almost like C++, and you say, okay, I expect my design to behave like this. I want to have, a processor of this size, word length, and so forth. And we help take that high-level description and compile it down into transistors and gates. When you're ready to tape out, you have to do all this stuff called design rule checking, right? So TSMC, all these foundries, global foundries, Samsung, they have rules. They say, okay, you can't have corners. You can't have your wire bend at a 90-degree angle, or no, you can't have two wires right next to each other. That violates the rules, right? And so there are all these rules that you have to check. And obviously, this has to be automated. You can't do this manually, right? So we have tools that run really quickly and check all the design rules for you. And that's called silicon sign-off and verification, separate from the verification here for system verification. Next is custom IC and PCB. So even if you're not like an electrical engineer, we do a lot of mechanical stuff too. So if you're thinking about heat wave equations, right, that's where Celsius comes in, electrothermal analysis, clarity, electromagnetic analysis, electromagnetic interference. And obviously voltage is our power integrity analysis. This is the gold standard for checking, down to the clock cycle, how much power in each clock cycle of my chip is being used. And two big PCB products, Allegro and OrCAD. So these compete with all the other PCB products out there. And so we have a huge library of vendors you can use to design your PCB. Virtuoso is kind of our bread and butter. This is kind of how I found Cadence, is that I took a class on analog design and I use Virtuoso. And so that's how I said, okay, well, who makes this product? Cadence. Oh, look, they're in San Jose. I'm nearby. Let me go talk to them. Next up, system verification. This is where I work. Let's see if I click. It should show up. Click. Is it not working? Advanced. Next slide. Okay, there we go. So I work on Palladium and Protium in hardware system verification. So we'll talk more about this later. But for right now, I want to highlight verification IP. So what is verification IP? This is important. So you're designing a chip and you want to conform to the USB-C standard, right? You've probably heard of USB-C. And you make this chip, how do you know that you're conforming to the specification? We sell a product called verification IP, which tests your design and says, check, 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 you've successfully implemented the specification. So whether it's DisplayPort, USB-C, all these standards. And it goes even deeper than that because actually Cadence is involved in the creation of these standards too. So for USB-C, we're on these forums that are talking about, okay, how's the USB-C specification actually going to be implemented? So even though Cadence isn't involved in a lot of consumer-facing, retail, products that you can necessarily buy in a store, we're making the ports, right? We're involved heavily in the specification of these protocols that end up being used in your consumer products. Intellectual property. So I talked about this before. This is a really hot business right now, right? So imaging neural networks, Internet of Things, audio, voice, and speech processing, right? So if you have a Google Home or Alexa, right? All those sort of DSPs are being embedded. Digital signal processors are being embedded into these custom chips. And so you can buy those from us or work on them too if you come work for the IP business. Yeah, so 8,900 employees worldwide, 5,500 R&D engineers and growing. If you join us, you can help grow that number. And then 1,900 field engineers. And so this is from our press release, July 2020. And we invest over, I'm trying to read a note here or see if it disappeared, but I think we invest over a third of our revenue into R&D. So there's a lot of a culture of innovation where we actually take our profits and invest it back in the company to grow. Yeah. 2.68 billion in revenue in 2020. Remember this, 20 plus significant new products in 3 years. So we're not just maintaining the stuff that we have right now, we're actually launching new products. So this is kind of an example of the heat solver I was talking about before, Celsius, right? So that modeling heat waves. 1,500 patents worldwide and 26 global development centers. And so we filed 1,500 patents, which is, since Cadence was founded over 30 years ago, which is more than any other EDA company. So we're proud of that culture of innovation and it gets recognized. Let's do next. Okay, and so this is the final intro slide. Tomorrow's world is built with Cadence. So 5G, edge computing, that's something I'm really excited about, right? So we've all been stuck at home with perhaps terrible home internet. You guys are at San Jose State University. You've probably seen the little 5G microcells go up all around downtown. And so this is going to become a popular thing now, is that I think Verizon is going to start selling a home 5G service. So imagine you don't like AT&T or Comcast, now you're going to have like 10 different options for your home internet. And that's going to be, bringing prices down, and that's all enabled by 5G. Deep learning, obviously you can't build a autonomous self-driving car without deep learning. Aerospace and defense, we didn't really touch on this one, but defense contractors are always building custom chips, right? You just never hear about them because that's kind of the point, right? They're secret. So what I'm most excited about is, one, the 5G, and number two, I think really ARM pushing their way into the server market. So pretty soon, when you go to AWS and request a server instance, in fact, this is true right now, there's a collaboration called Annapurna Labs where they have a custom built ARM core. So you don't have to use x86 or AMD core if you don't want. You can use a low power core and perhaps even save some money in the process by using this low power core, because it costs Amazon or these cloud providers less money to run, right? So these gains, incremental gains, start adding up, and Cadence is at the center of helping people design those incremental gains. Okay, so we're going to move on to projects, talk a little bit about what I've been doing. So like I said in the beginning, I'm Daniel Fernandez. I'm a lead software engineer at Cadence. I work on the hardware system verification research and development team. It's my first job right out of school. So I did my bachelor's in computer engineering at UIUC in Urbana-Champaign. That's like 3 hours south of Chicago by car, in the middle of nowhere pretty much. But if you fly into Urbana-Champaign, it's literally a cornfield. I don't know if they did that on purpose, but they like cut the runway out of the cornfield. But if you can afford a jet down there, that's what you'll see. Stanford University, I came back. So I'm actually from San Jose. I just went to school out in Illinois. And so I came back to do my master's up the road at Stanford. Did that for 2 years and joined Cadence right after in April 2019. So I'm coming up on 2 years right now. What is emulation? What is prototyping? So this is the first question that I had when I joined hardware system verification, is that we make two appliances and they look kind of similar and it seemed like they kind of do the same thing. So I was kind of wondering, okay, well, emulation and prototyping, they sound kind of similar. Is there really a difference? Why do you have to sell both of them? Is one replacing the other, right? So are you like cannibalizing your, other side of the business? No, it turns out that's not what's happening. Is that they're actually kind of pretty different with pretty different applications. So emulators are fast to compile, within a day, like less than 24 hours, you can have this emulator up and running from your idea that you type into the computer to have it running on an emulator, within a day. But they're slower to run than prototyping. This is Protium on the left, which is our prototyping platform. But slower is a relative term, right? This emulator, which we call Palladium Z1, is much faster than a software simulator. So it depends where you are in your classes. You may have had, you may have written some Verilog or written some VHDL, and you may have run it in a software simulator. But once you start to build a system on chip and you have millions and billions of nets, that software simulator becomes really, really slow. And it doesn't matter if you buy a faster, server with, 64 cores or the latest and greatest, thing that you can rent from AWS. People still do that. It's just really, really slow, right? Compared to this emulator. The other point I want to mention is that you can get detailed traces of every net in the design. Full control over starting and stopping and forcing net values. So if you have multiple clocks in your design, you can start and stop anywhere that you want, full control. Kind of like it acts like you're using a software platform, but you're really using a hardware platform without realizing it. Sometimes emulators are custom silicon. Our competitors don't use custom silicon. The reason I mention this is because we do. Like I'm kind of involved in the development of this custom ASIC that we put into the Palladium Z1. And that's kind of what the special sauce that makes it a better product than anything else out there on the market. And all these points are leading up to this final point, which is the best for hardware designers. So if you're running a test bench to find bugs or doing what we call in-circuit emulation, this is really cool. There's a YouTube video of NVIDIA's emulation lab where they use our Cadence emulators. NVIDIA is making a GPU and they want to test it. They can take the pins out of the back of this emulator and plug it into a monitor, right? Or plug it into a PCIe port on a test computer. And this whole box becomes a GPU. It's identical. It's functionally equivalent. It's the exact same thing as what they're going to get back from the foundry if they were to tape out the chip and send it and wait a year for it to come back, right? And that's kind of amazing when you think about it. It's that, an engineer just has an idea. They can hit enter on a computer. They can have the chip, the pins of the chip coming out the back of this box. And it'll run slower. Yes, it's not as fast as obviously the real silicon, but you've got the chip pretty much in your hands, right? And you can change it day by day. And that's kind of the amazing fact about all of this. And on the other hand, what is prototyping? So as you can probably imagine, prototyping is slow to compile because There are FPGAs, if you guys have used FPGAs in any of your classes, field programmable gate arrays. It takes a while for, there's some mechanics to the computation or compilation process for place and route and this kind of stuff that makes it slow to compile. So it might, if you have a huge design, it might take like, a couple of days to a week. But once you do that, it's really fast to run, right? That's what you're investing this time upfront to get a faster system. These tend to be just FPGAs united by a backplane. So we use Xilinx FPGAs in this Protium system, and we provide the backplane and all the infrastructure around it. There's limited ability to inspect nets and force net values, right? So it's not really a great debugging platform per se compared to Palladium, which is our emulator. But yeah, this is all leading up to this point, which is that it's the best for software and firmware engineers. So this is the amazing thing about Protium, is that let's say you're building a smartphone. You want to boot Android and start bringing up the firmware for your smartphone before the chip comes back, right? You need to get it ready in time for Christmas. So you go send out the chip a couple of months before. The chip isn't. You're not going to see that for a couple of months. You can start bringing up Android, start writing the firmware. All your Linux developers can start booting Linux on this chip that doesn't even exist yet. And so when the chip comes back, you've written all the software and you just push a button, put the software on there, and it's ready to go. So this is really like prototyping kind of thing about it, adding all the system peripherals and the touchscreen, all that stuff together. To build a system. And so we sell this as the dynamic duo, Palladium and Protium. So on the one hand, you can take that same database of what we call RTL, registered transfer language, and throw it on the Palladium if you're a hardware designer and do some debug, or throw it on the Protium and do some prototyping. And what we're trying to do is make this loop between you building something, allocating it onto this emulator system, running it and debugging it, and making that loop faster and faster and faster. And that's the name of the game, because it turns out like 3/4 of your costs in building a chip end up being verification costs, just finding bugs. I didn't mention this point before, but Palladium runs at about like 1 megahertz, and Protium can run from 2.5 to 5 megahertz for big designs and tens of megahertz for smaller designs. So you're getting a sense of the scale here for how fast things can run. And so the point I want to nail home is that, you think about Cadence as a software company, is that actually we build supercomputers. Most people don't know this. So maybe you guys have heard about Seymour Cray. If you've been to the Computer History Museum, you can go see the Cray, I think it's S1 supercomputer. And what they'll mention on the tour, what Seymour Cray was famous for was measuring the lengths of wires and changing the geometry of his computer into like a cylinder so that he could shorten the wire lengths. And this mattered to him. Like he knew every transistor or every vacuum tube inside of his system, and he would measure, right? Because longer wires it takes longer for the signal to propagate, and you can't run the system as fast. So he was famous for measuring the length of wires and changing, the physical configuration of this computer just to eke out a little bit more performance. And that's actually something that we do in Palladium, right? The design of this Palladium rack is not just like a bunch of independent servers all strung together on a rack. And, it doesn't really matter if you put this rack over here in the next room somewhere. No, these four, if you have 4 racks, they actually have to be next to each other because we're measuring the wires, right? It actually matters how far apart, these optical cables are from one another, or how fast these SerDes links, what we call serializer, deserializer links are spaced from one another. And so there's a topology to all of this that we're engineering. And so I stole this quote from this article. This is from Frank Schurmeister, who's one of our marketing guys. And I'll read it out to you. He's talking about Fujitsu, giving a talk about their K1 supercomputer, disclosed how about 100,000 high-performance CPUs are densely connected through their own interconnect chip. ... Having been closely involved in the development of Palladium Z1, this looks very familiar, right? And so, when you think about supercomputers, you should also think about Cadence too, because what we're building is also a supercomputer. And why do we do this? To find bugs. right? So I mentioned this loop before. I didn't spend as much time talking about allocation, but this is actually a key feature about this Palladium system, is that multiple users can use the same emulator at the same time. So before, you'd have to like book an emulator, you'd have multiple of them, and only one engineer could use it at a time. Now, if you have a job that only uses half the emulator, you can have multiple engineers working on the same emulator and move jobs around. And so it's becoming what we call cloudable. And there's actually something called Palladium Cloud, where you can go rent out a Palladium for a day if you don't have time or money to buy the whole enchilada yourself. You also have to set up water cooling because it gets really hot, but that's a separate issue. But yeah, making this loop as fast as possible so you can find as many bugs as possible. And what happens if you don't find bugs? If you've never heard about processor bugs, you may still have heard about the Pentium F Div bug. So this is a 2014 article. It says 20 years later, because this was in 1994. Intel had a bug in their Pentium processors, or a certain line of them. You could actually see this in Windows. If you went to go divide two numbers, it turns out at like the 4th decimal place for certain values of your operands, it would get the wrong value. And so it took a while it wasn't a glaring error. It was like out in, the 4th decimal place for some values, right? So it wasn't that obvious, but a mathematician at Lynchburg University discovered this, and, he wrote a letter and said, hey, as a mathematician, I know random numbers, decimal points are roughly supposed to be distributed in this sort of way. And using number theory, I can see that there's something wrong with how Intel's implemented the spec here. And this became a huge scandal, and it cost Intel, I think, something like $500 million in 1994 dollars. So you can imagine how much it would cost today. And so that's you can imagine if Apple had a recall for an iPhone, right? AntennaGate was one thing, but you can imagine oh, actually, there's something wrong with the new A12 processor. We need to recall all iPhones. How terrible that would be, right? And so, doing the work up front, our job is to help you find as many bugs as possible in this tight time frame between Christmas to Christmas, so that you can, launch a successful product. Or if you do find bugs, because all processors secretly do have bugs, you can sweep them under the rug, and so the user will never see them, right? And so this is specifically what I've been working on recently, is that Palladium was never really meant to be a power estimation tool per se, right? But it turns out you can estimate power using Palladium, because as it turns out, net switching and toggles equals power, right? So when you have a wire inside a circuit and you charge that wire up with a battery or some voltage, that requires energy. And when you drain that voltage off that wire, now you're dissipating the energy as heat. And so that's the essence of power, is that switching equals power. When you're not switching nets, then you're not consuming power most of the time. There's some stuff called static power, but let's ignore that for now. And so power is roughly what we call half CV squared times half. So capacitance is C is the capacitance of the wire, how big the wire is, how long the wire is. Voltage is how, obviously what voltage your processor chip is running at, and frequency, right? So as your frequency gets higher and higher and higher, you're using more power, obviously. And so we can do this right now, is that we can count the number of toggles and give you a rough estimate of how much power your chip is using, or your design is using, for a given stimulus that you provide. But it turns out there's another source of power called glitches. So glitches are unnecessary toggles caused by propagation delay in a circuit. And Palladium is delay and timing problem free. That's how we designed it, so that there's never a problem with timing or the real stuff of silicon. It's all about testing your functional design. So there's no glitch toggles that are possible. And so the question is, how can we estimate glitch? And over here, I gave an example of a circuit that glitches. So if I have some input here, I have, let's say, it's input ANDed with not input. And so this would always be 0, right? Because A and not A is always false. And so I've got a NOT gate here and a unit delay. You can see when the input net 0 goes high, there's a 1 unit delay before net 1 drops down. And then net 2, the output here, sees this net 0 before net 1 has a chance to also go low. So for a brief moment of time, a blip, you get a glitch, right? It went from 0 to 1 to 0 and wasn't supposed to go to 1. And so this is wasted power right here. And there are ways to design around this, but first you have to see the problem before you can design around it. And so that's what we're trying to do. And so how do we do this? We're starting to do something what we call probabilistic glitch. And so the idea here is that nets that toggle more have more of a chance of glitching, right? So if you have a net that doesn't, the inverse isn't true. If you have a net that doesn't toggle at all, that doesn't mean it can't glitch. It just has less chance of glitching because there's less activity happening there generally. And so the idea here is that every, like I talked about on the previous slide, every 0 to 1 to 0 transition is a chance to glitch, or the inverse is also true, 1 to 0 to 1. And every 0 to 1 or 1 to 0 transition is a chance to propagate a glitch. So what I'm talking about is this K-map. You guys have, maybe depends what level in your classes are, you may or may not have seen K-maps, or also I guess depends on your field. If you're a computer science person, you might not have seen K-maps. But this is just an unfolding of the combinational logic in this circuit. So you can see like when A, B, C, D are all 0 or false, the output is 0. And that's what this K-map describes. And the blue arrows here are 0, 1, 0 or 1, 0, 1 transitions. So you can imagine in this entire state space of for all possible combinational inputs to this combinational circuit, when you have more blue arrows, more chances to go from 0 to 1 to 0, that snippet, I guess, of the combinational circuit is more likely to generate a glitch, just generally. And all these 1 to 0, 1 to 0, or 0 to 1, that's a chance for a propagated glitch, or for you to propagate a glitch that was generated behind you, right? So we're combining these two facts, that you have glitches that are generated, and then certain parts of the circuit that propagate those glitches. And so we're just building a statistical model that does that tries and looks at your netlist and says, okay, based on how this netlist is designed, we think that these gates are going to have a high chance of glitching, and we think that they have a high chance of propagating the glitch, and we're going to add some extra toggles to your netlist. And so we do this, we verify with the gold standard, we run Voltus, which is one of the tools I talked about earlier, is that we compare. We say, okay, let's try and do some glitch estimation and compare to the gold standard and see how well we've done. And so now we're actually seeing some success doing that. And so you can imagine if you're a smartphone designer, you want to get the lowest power possible, you can run a stimulus, run a test bench, and start to get an idea about where you should start focusing your design efforts, and say like, oh, when we start doing multiplies, because multipliers tend to be actually quite glitchy in the circuit, we see a lot of glitch power over here. How can we design that away? That's the idea. And so hopefully you'll get smartphones that last 2 days instead of 1 day. That's the goal here. Okay, so now shifting from what I've done to what you guys can do. I pulled an article from Breakfast Bites, Paul McClelland's blog. This is from 2019, what we call the CHIPS, College Hire and Internship Program. So this was in 2019, we had 358 interns, and 133 of which were in the Americas, and 63 of which were in San Jose. So we also have offices in Austin, Texas, and Chelmsford, Massachusetts, interns in Brazil. We have a big office in Noida, India, which is right outside of New Delhi. So interns around the world. And so interns are assigned real life problems to solve. You get to report to your manager, you're assigned a buddy to. Oh, someone was talking.
Sorry.
Oh.
Like trying to brush my teeth really quick. Fine.
Oh. Sorry, Edelyn. Okay.
Hey, Len,
okay.
I put you on mute, so you're all set now.
That's fine. Yeah, no problem. So yeah, they're interesting and challenging projects for you to do. You can go just Google for Breakfast Bites Interns 2019, and this is the first thing that'll come up. I think we'll push out the PDF later if you guys want to click on these links. This is another article that I really liked. I pulled it down from Breakfast Bites from Paul McClelland's blog, and it's titled "Why Millennial Engineers Should Work for Cadence." And so I'll read this quote out to you. My friend's sister was around 40, this is Paul McClellan speaking, and was thinking that maybe she should quit Nokia and join an NGO and quote unquote make more of a difference. I argued with her that Nokia was already making far more of a difference in Africa than all the NGOs put together, and her small part in it was the best way for her to fight injustice and make that difference. Cell phones had allowed individuals to control their lives like never before, and mobile phones changed all that. And so he also goes on to tell a story, you know, if you're a fisherman and you know, coming in the port and you have 3 different markets to go to, you can make a phone call and say, okay, market 1, what's the going rate for tuna, right? And you can start steering your boat and say, okay, I'm going over to where the fish is high in demand, right? And so that's making you more money. One of the big applications which you may have heard about is Mpesa, right? So mobile wallets. If you are working in a city and you need to send money back home to a village, right? And that village doesn't have banking infrastructure, you know, you can send money through your phone. If they have phones, you have phones, you know, radios everywhere, ubiquitous. Boom, that's a huge application right there. So yeah, that's kind of the leverage of being an engineer, is that, you know, when you sit as a Cadence engineer, you sit so, you know, far back in the supply chain where what you do has a huge effect on the rest of the industry, whether they know it or not. I put in here, I'm not going to go through the whole genealogy of Cadence, but suffice it to say is that, you know, Cadence was formed as a bunch of mergers over time. So it started with in 1988 as the merger between SDA Systems and ECAD. You can go read these blog articles for a brief history of Cadence. And, you know, this is how Cadence has grown over time. And I guess there was a dark side to this, is that people started to become more siloed, right? It started to feel like, I guess I wasn't there because, you know, I only joined 2 years ago, but it started, from more reports, it started to feel like, you know, multiple different companies that weren't talking to each other within one big company. And then so in 2008, it wasn't sure, is Cadence going to survive? We don't know. And so I'll read this quote out to you. When the 2008 recession hit and the market questioned Cadence future, the company leadership looked to its culture for the answer, inspired by an unlikely venture capitalist turned CEO, who's Lip Bhutan over here. Whose practices purposeful and inclusive leadership, Cadence re-engaged its highly skilled and experienced workforce and wooed skeptical customers. And so how do we change our culture? Well, first we started emphasizing one Cadence, one team. So you'll see banners about this if you come work at Cadence in the cafeteria. And the 4 E's, right? So exceed customer expectations, explore what's possible, execute with quality, elevate the team, right? So don't be focused on short-term sales goals, right? We're focused on helping our customers win. And then when our customers win, we win. So that's kind of the last point, win with the winners. So I mentioned this earlier, is that a whole bunch of companies that you thought would never be designing chips, like why is Facebook designing chips, right? Well, they have a division called Oculus where they're making augmented reality goggles, right? So all these, you know, Google's making chips, all these companies that you thought were just software, you know, obviously Apple's making chips right now, but for a long time, they would never touch a chip. They just had suppliers like Motorola and Intel. And so a whole bunch of companies that you thought never in a million years would be making chips because of this fabulous semiconductor revolution, you know, the costs have come down appreciably, right? And so now it becomes more economical to add your special sauce and make your own special chip. And that's what's growing Cadence, quite frankly. So you can go download this report if you're more interested in it, Cadence and the Culture Cure. It's over here at this link. Another blog post from Breakfast Bites, how to land a job at Cadence. This is kind of general advice, you know, not just for Cadence, but really for any company. This is from Craig Myers. Be sure to convey that you have used the skills you've learned in school, even if your project experience is only academic. Taking classes is great, but showing potential employers how you apply your knowledge is essential. So you can go read this article over here and read about our summer internships and yeah, write a cover letter is my advice, right? You know, go write, you know, when you apply for a job and you have an opportunity to write a cover letter, definitely do it. Life at Cadence. So many fun events for all employees. So there are intern-only events in the summer. You know, usually we go to Great America. I guess Eddie Solis Jr. may want to take us to paintball one day, but we'll see about that. town halls with executive management team, educational events, social events, great food. So our cafeteria, it's good. There's like sushi on Monday and Friday. And if you guys are familiar with the Umi hand roll bar, you guys are in SJSU, right? So I assume you guys go to Sofa Market occasionally. It's like the same like hand rolled sushi. You can come get it at Cadence, and it's actually open, to other employees too. So there are always employees from other companies nearby Cadence coming to eat at Cadence. There's an on-site gym and classes. If you sign up, I think as an intern, you get free access to the gym, but otherwise it's like $15 or something like that, just to motivate you to go. There's Zumba and yoga. You can take as many classes as you want. There's basketball and beach volleyball teams. We have a beach volleyball court. So if you're into that, feel free to avail. I think we now have 2 basketball courts. There's like one behind building 11. So you can, we may start a league, you never know. Why work at Cadence? So doing meaningful work, truly a great place to work, very friendly atmosphere. Managers are industry experts. I want to dwell on this is that I feel like, everyone that I encounter is like way smarter than me. That's how it feels like. I'm learning something every day. It's a direct application of all your studies. So this is also an underrated point is that, if you're learning all these great things in school, Cadence has such a close partnership between academia. We hire a lot of academics, and a lot of academics work with Cadence, for their research. And so there's kind of this close-knit, this close relationship between what you're learning in school and what Cadence does. And so, if you're learning all this stuff about electrical engineering, about electronics or computer engineering, about C++ programming and how to optimize a system, all that stuff is directly applicable to what we do, right? So it's really, I feel like as a computer engineer, it's the perfect place for a computer engineer is that I'm really using my degree. Cadence is a great place to work. If you drive by our offices on Montague Expressway, you'll see the banner out there. And so, most people don't know what Cadence is, but they see the banner and they say, oh, Cadence, that's a great place to work, right? So that banner really does a lot of leverage for us. Yeah, Fortune 100 best companies to work for. We recently got this award from the Human Rights Campaign, 100% Corporate Equality Index. Let me just read the notes so I don't miss any of the points here. We've been recognized as a great place to work 6 years in a row. So that may come up later, so remember that. We are also recognized in 13 countries across the world, earning us a spot on the world's best workplaces list in 2020. Additionally, we recently received a corporate equality index score of 100% for LGBTQ inclusive workplace policies and practices. Yeah, I think that's all I wanted to say about that. Go to the next slide. Commitment to employees, benefits, and culture. So we have great benefits, medical, dental, vision, and more. Unique benefits. So there's stuff like car washes. I think there's also those purple trucks that come by and fill your gas tank, right? So if you are running low on gas, they'll put gas in your vehicle at Costco prices. It's pretty amazing. Home, auto, and pet insurance, legal advice, unlimited sick days. So we do flexible time off. So you just work with your manager and say, hey, I need to take some time off, and there's no like set amount of time, right? You just work with your manager to do that, which is great. Employee volunteer time. So you get 5 days per person per year in paid volunteer time. So if you want to go work at Habitat for Humanity or something like that, you'll get paid to do that. Matching gifts, so $1,000 per person per year, and actually we upped that last year in the pandemic, so for 2,000, and I took advantage of that. Community, so we host something called Women at Cadence, so the Women at Cadence speaker program and networking events, and we offer employee-led inclusion groups for a variety of diverse backgrounds. And in addition, we support diversity in technology. So we've now recently partnered with Black Girls Code, Latinas in Tech, Out in Tech for LGBTQ employees, and Veterans in Tech, Vets in Tech. So 96 employees feel Cadence is inclusive and fair place to work, and we're happy about that. So more about commitment to employees. Professional growth, so personalized learning courses. This is actually an underrated perk I want to mention, is that we have something called Cadence Online Learning, or hopefully I'm getting that, COL, yeah. So employees of other companies come pay to have their employees come to Cadence and learn about our tools and learn how to use our tools. And so you as a Cadence employee can get free access to all that training. So the kind of stuff that other employers are paying their employees to come to Cadence and learn, you can take those courses online at your own pace, or if there are in-person classes and time is permitting, you can take them in person too. We have a hackathon every year, Emerging Technology Task Force. So especially for AI and machine learning, we've started to have a task force that gives talks and networking events specifically on AI and ML and how that's going to impact Cadence. Technical and professional development workshops. I know IEEE has come by multiple times to give speeches, executive leadership roundtables, and more. So 94% of employees say they work on great challenges and have exciting opportunities to innovate. We also have this thing called the Shine Employee Recognition Program. If another employee wants to recognize your hard work, there's like a gift card exchange system, so you can go get like a free lunch through that. And there are Cadence Achievement Awards, patent, invention, and innovation milestones. Let's see if there's anything else I want to mention about that. Yeah, I think that's it. So commitment to future innovators, I mentioned this a little bit earlier too. So since 2018, Cadence has been offering the Women in Technology Scholarship to students that identify as female pursuing a technical degree. And this year, we added the Black students and Latinx students in technology scholarship to broaden our reach of supporting diverse backgrounds. And so we're excited that we awarded 31 scholarships this year and provided $285,000 in scholarship funding since 2018. So we want to foster environmental inclusion and support the next generation of innovators. So tomorrow's world is built on Cadence. So you can go to this URL, cadence.com/go/university-careers. And I think that's the last slide. Okay. We're done. I'll leave that up there. Oh, now it's time for a quiz. So I'm going to switch to Kahoot. So if you guys want to get out your phones, let's see if the audio comes through. So if you have a phone, go pull out, go to www.kahoot.it, and then type in this pin. All right, great. Got 39 people. Okay, we're up to 9. You guys will enjoy the animations. Maybe you guys have seen Kahoot before, but it's entertaining even if you don't get the answers right. So, but they're pretty easy. Hopefully the audio is coming through not too loud. I can turn it down if it's too high.
The audio sounds fine on my end.
Okay. Okay, so you got 22 people. Is everyone ready? Oh, you got more people coming? Okay, so I'll pause for a little bit longer. Okay, I think we've stabilized roughly 25. Okay, it looks good to me. Okay. Okay, we're in, oh. Okay, I guess you can also keep joining while the game is going on. So it's not that critical that everyone joins right when it hits start. So I'm gonna go ahead and start the game. So get ready. So you could choose electronic design is awesome. That was also a valid choice. Okay, good job. Oh, congrats, Sai. Correct, Seymour Cray. Oh, Gordon Moore. Okay, a lot of people thought it was Gordon Moore. He does look like Gordon Moore, to be fair, or maybe Robert Noyce. I forget which one is which, but they do look like the Intel guys, to be honest. Yeah. Nice. 15 correct. Good job, guys. Oh, Z is on fire. Wow, I didn't you could have a fire streak. I'm learning every day. There you go. Okay. Good job. Oh, wow. High flyer or climbing up Kanika. Good job. Okay, so I think there's no wrong answer here. Wow, roughly even distribution, but a lot of people in 5G. I guess I sold the 5G aspect. Congrats, Sai. Congrats, Erica. Wow, Z, whoever Z is. And runners up, HA and Suj. So you get the confetti, you get the full animation experience. There's also a feedback thing here. Okay, so this was a difficult question. Yeah, this was Seymour Cray, famous for digging tunnels underneath his home in Minnesota. So I think I always think about Elon Musk, right? He wants to dig tunnels. Seymour Cray wants to dig tunnels. I think once you get to a certain level, you just go crazy and wanting to dig tunnels everywhere. So, okay, you can give feedback if you want. It'll just pop up in there if you were happy or sad with the quiz. So I think that's it. I guess I'll just stop sharing and we can move to Q&A. So I open up the chat box.
So Daniel, would you prefer that students like type in their questions in like the chat box, or just like unmute and like openly voice their questions?
It would be nice to hear people's voices. That would be, you can do it either way. If you're shy, you can type it in the chat box, but if you'd like to, I guess, Patrick, if you want to have people raise their hands or however you want to do it.
It's up to you. So so for attendees, if you the floor is yours if you'd like to unmute and ask your questions.
Sure.
Hello. Hi, this is Soumya. I believe Cadence is into building tools for electronic design automation, mainly for chip makers. How do you plan on leveraging deep learning or AI into that?
Sure, good question. So right now, there are a lot of applications basically because there's so much data, and machine learning is driven by data, and we have lots of data because we have lots of chip designs. So with that huge, these designs run into gigabytes and terabytes of data, and that's all becomes a training set for us to, learn something and produce better results. So one thing I'm thinking about is place and route. So place and route, where you place the wires down on a PCB or on a, on a silicon wafer. There's kind of an art form to it, but because we have so many designs, we can start learning about the best way to do place and route without just doing something brute force, like simulated annealing, which is kind of the traditional method of doing these kind of things, or quadratic placement. You can read all about these EDA algorithms, and they're kind of simple, right? They don't use data. They don't use anything that we've learned in the past to inform the future. So that's one application, is just layout and planning of a chip. We've also launched a product recently called Excellium ML, and ML is for machine learning, where we are now, for our verification platform, we're trying to find bugs. We now build a database that actually has some smarts to it and tries test vectors or tries to steer the verification test plan to find bugs in your system faster, right? And so that's something we can do with machine learning, is use the database of past bugs or past design stimuluses to find bugs faster in the future. And so that's something that we've started to do and launched. And so there are a bunch of more things like that, just waiting in the wings. I see a question from Erica Son. How would a electrical engineering background with masters with some experience with Virtuoso Inspector help contribute to projects? So when I came to Cadence, I started using Virtuoso. Well, I had used Virtuoso, and that's how I applied to Cadence. So if you can, there are a bunch of roles. So if you're able to do C++ or you're interested in chip design per se, then you'd want to look more at the IP group. So the IP group, we build ADCs and DACs, so mixed signal designs, right? And that's something we do under the umbrella of the IP group, and we've started making more acquisitions and analog design, RF circuits, that kind of thing for 5G. So it depends how you want to steer your career. You can either go more into software if you're interested in the software behind the tool, how Virtuoso is made, or you're interested in applying the tool, you can go do that in the IP group. Or if you join hardware system verification, where I'm at, you can use our tools to create better emulators. So we use our own tools to create the ASIC chip that goes into Palladium C1. So there are a lot of different applications, and you kind of you can look at the job description and get an idea of like, oh, I want to apply my analog signal design background. I want to use the tools, or I want to be a developer of the tools. You kind of get to pick, and you can transition between either one, quite frankly. I see another one from Nikita Molokar. What do you expect from an entry-level engineer? Any particular skill set? For example, an ASIC design engineer. It's probably it depends for if you're doing an internship or full-time. If you're an intern, the requirements are probably less, but the questions I've seen are stuff like asynchronous FIFOs for ASIC designers. So stuff like that, if you go through interview questions, it'll be a lot of the stuff in your classes, quite frankly. So if you're taking digital design classes, for full-time, please. Yeah, so I can only speak to, as a software engineer, what I do to be a software engineer. But I don't know, does anyone else want to
So I'll chime in real quickly and just say that I think overall, looking for that natural curiosity, the desire to solve problems, we're solving, as Daniel highlighted, we're solving problems that are significantly more challenging than putting the latest and greatest airplanes together. And the problem only gets significantly more challenging every 2 years as it doubles in complexity. Even if Moore's law is slowing down, maybe it's every 3 years, still it's getting twice as challenging every few years. And we need people that are willing to take on that challenge of solving problems that today we don't know how to solve, and we want those ideas coming in. And so people that are willing to step up and contribute their ideas, not afraid of failure, and willing to figure out how to do course corrections, but continuously learn and be willing to innovate. So
nice. I see a DM here. Oh, okay. So I see a DM, but I'll just read out the general question. So the general question is, how probable is it for the chip design to be fully automated without human intervention? It would be as easy as where you type in the specifications of a chip and the chip comes out the other end. Is such a scenario even possible? So yes, people have talked about this. There is a DARPA project, I believe, on like push button design. But we do similar things already in the IP group because you can customize a DSP core to your liking. And if you're running Cadence full flow, it's not like literally push button, but it's as close as you can get because you can use all our tools on AWS. You don't have to install them necessarily on your own, set up your own machine. And you can start specifying how big your register file is going to be and that kind of stuff. And when you start working with us, then you have a whole design team there to help you, assist you. So it's almost like a push button, if not like, specifically a button that you push, I guess. I see another question here. Hi, Daniel, regarding the internship listings on the Cadence site. They have Unix, Linux experience as a strong plus. What specific experience in Linux would that entail? So I would say command line experience, right? So you should be able to work your way around a command line, SSH, because all our machines are behind a VPN. So you never actually get in front of a machine, you SSH into a data center, and we use VNC, so virtual, I forget what VNC actually stands for, but it's basically remote desktop, right? So we have a lot of secure projects, and we keep them in a data chamber, so none of our data leaks out. So that's the thrust of it. It depends what role you're taking on. If you're taking on the role of a ASIC designer, then it's more about using the tools than developing the tools, right? So you'll be doing less programming, but you might be doing more visual stuff, right? If you're doing schematic layout or PCB layout or something like that. So yeah, it it depends on your job description, but it's going to be those general Unix and Linux skills that you can kind of pick up out of a book, quite frankly. I see another question from Swati. Can graduate student having more than 5 years of irrelevant past work experience apply for software engineer entry-level job positions, or should apply to only senior level positions?
I said yes.
Sorry, is that for me or?
No, I don't think so, but I don't want to renew it.
Oh, I guess that's not for me. Okay. Yeah, does anyone on the recruiting team want to take this on? So if you have a graduate student who has 5 years of irrelevant past work experience, apply for software engineer entry-level positions, or should only apply to senior level positions? That's an interesting question because I'm not sure what counts as years of experience to the recruitment team?
Yeah, I could take that one, Daniel. Thanks. Yeah, I mean, we consider previous experience prior to your master's, but we look at, is this experience relevant to the position you're applying for? So it kind of depends. I would look at the job requirements, and if it says that we're looking for someone with 5 years of experience, then and you have that previous experience, I would definitely apply for it. So it kind of depends. And some hiring managers, we're open to anywhere from like a new grad level up to someone with more experience. So it kind of really depends. But I would apply for both new grad positions as well as senior level positions too. But usually they actually list how much years of experience they're looking for.
Yeah. And also my interview experience at Cadence is that I applied for one job, but ended up, interviewing with a bunch of different groups. So just because you apply to one job doesn't mean, your recruiter can also work with you and say like, hey, actually, there's this other group over here that may be a better fit for you or want your specific skill set more. Would you be interested in that? And so I ended up doing I think 3 or 4 different interviews with different groups. And at the end of the day, I got to pick, right? They actually said like, hey, all these groups are interested in you. What are you interested in? So sometimes that question can be turned on its head, is that, if you do enough interviews, you may be the one ending up picking and saying like, hey, I want to be going in this direction. I see another question from Shruti. Hi, I see there are different levels like software engineer 1, 2, 3 in the Cadence career site. Can you please talk about the difference, like years of experience required for each of them? Yeah, you want to take that?
Yeah, I can take that one. So usually a software engineer 1, that would be for a new grad with like a bachelor's degree and no years of experience, or maybe 1 to 2 years of experience. Typically the software engineer 2 is a master's graduate, typically with a few years of experience, or a lot of times no experience. And then a level 3 is typically master's with maybe 2 to 3 years of experience, or a PhD new grad. That's typically how we level everyone.
Nice. Yeah, that's my experience, because I came with a master's and I think I came in at 2. So yeah. I see a question. Are there any available positions for data analyst roles? So data analyst, you guys know more about that than me. I imagine, I wonder if this is like more related to sales than, or yeah, you can go to our career page and see if you see keywords that are fitting what you're looking for. But definitely we have a huge, if you're talking about data analysts, because usually I think about sales, we have a huge, every single division in Cadence has its own like marketing team and sales team that are looking at how our people are using our products and what the customer wants. So
are you done hiring interns for summer internship, or is the process still ongoing?
Yeah, it's still ongoing. So I recruit for our custom IC PCB design group, and I think majority of our summer positions are not open yet. So we're kind of late in the game. But yeah, I mean, I think last time I checked, we had, let me see here. It looks like there's, in the US, looks like we only have 13 postings. But yeah, we're going to be opening up a bunch more in the coming weeks. So I would recommend checking our site now, and then every few days check back, because yeah, we're going to be opening up a lot more.
How do we we get a resume noticed in the sense, like in the past also I've applied for internships at Cadence. I've also applied for returnship program because I qualify for both. I'm a returnship candidate as well as I'm pursuing masters right now, so I'm eligible to apply for internship too. But I've never received any kind of response from Cadence. Uh, what is the best way to make my resume reach the recruiter or the hiring manager?
Yeah, well, it helps that you attended this event today, so you can get in touch with me. But I mean, we have hundreds of people applying for these intern positions, so it could definitely be challenging. And if we don't get back to you, don't get discouraged because there's a lot of people applying. Yeah, I mean, again, attending these types of events helps because we know that you're interested in Cadence. Encourage you to keep applying. We have a lot of positions opening up, and when you do apply, make sure to when you apply, there's like a source section, and so it would be a good idea to enter in how you found out about the position. I'm not sure what the exact kind of selection would be for this thing. I think it's like I don't know if there's like something for the info session, but you could put like career fair that way. It kind of stands out. We know that we may have talked to you at some kind of event or career fair, virtual career fair. So that will help us kind of distinguish you amongst all the different candidates applying.
Yeah, I just posted the link to how to land a job at Cadence on our Breakfast Bites blog. And yeah, my tip is write a cover letter, because then you're helping to personalize your resume, because it can kind of feel like when you send out a resume, if it's a resume that you could have sent to any employer, then really what good does it do? It doesn't show that that you didn't just send out your resume to a billion companies, and it's not really targeted to any actual position at the company. So if you start putting in your cover letter and say like, hey, I read about this question, here's what's on my resume, here are my plans, I'm planning to do a master's, and you can start to personalize and say like, I'm applying to the internship because I'm planning on doing a master's, and here are the classes that I've taken. Start directing and selling yourself in your cover letter to like, here are the things that, the relevant lines of experience in my resume that you should be looking at, or that I want you to pay attention to, that I think are the best fit for me at Cadence. So it's kind of like managing up, help your recruiter help you by telling your story in your own voice. And what your plans are going forward. So yeah, because we've had interns that, repeat interns, that are interns that come back for 2 summers. And so, and then they end up joining us full time. So that's, once you get on that ladder, then it really becomes easier once you can sell yourself. Let's see, do I have a...
May I ask if
Yeah, go ahead.
Sorry. May I ask if I graduate this coming semester, will I still be eligible to apply for the internship? And do you have any advice for the electrical engineer apply for the firmware basics or hardware verifications engineering position as an undergraduate?
So the question tailed off a little bit there, but the first part was if you're doing a master's, so are you graduating, or are you going to be, the key point about an internship is that you're supposed to be returning to school after the internship is completed. So if you are returning to academia after the internship is completed, then you should apply for an internship. Otherwise, if you're not returning, then usually you want to go full time. That's how I think about it. Brian, do you want to add anything else to that, or?
Yeah, that's you're right on the money there. That's typically what I see most new grads doing. But we have hired new college grads that went on to do an internship. Doesn't happen often, but it does happen. Yeah, I mean, if you're finishing your master's this coming semester or quarter, you can apply for internship, but I kind of wonder why you would apply for internship as opposed to a full-time role. Yeah, it would depend on your specific situation.
Oh, sorry, I do not say, because I'm undergraduate, I'm not master's student.
You said you're a undergrad or a master's student? Undergrad student, okay.
Yeah.
Yes, and are you going to continue on to your master's, or?
I looking for, is there any like the program for co-op or entry level engineering position? Because a master is another like consideration.
Oh, go ahead, Daniel.
Yeah, so I guess you're kind of in the process of deciding whether you would want to continue on to a master's or if you should. Yeah, if you're, I would say, I don't think we have a co-op program, do we?
Sometimes we call it a co-op, but it's typically an internship.
Okay.
I think we kind of use them interchangeably at times, but for the most part, we usually call them internships.
Yeah, because co-op I usually think of, instead of a quarter with like 3 months, you're doing either a semester or a year-long stint. And it's more common in Canada than the United States. Yeah, then I would probably do an internship, right? So because if you have a master's acceptance letter in hand, you don't, then that signals that you're going back to that you have the opportunity to go back to academia. I'm not sure, as recruiters, Brian, do you guys verify that students are returning, or is it just like by word, or I don't know how that goes?
Yeah, I would say it's more by word, I guess. I don't really, I go off what they tell me and kind of what the resume says, but that's kind of beyond that. Pretty much what I do.
Yeah. Yeah, because yeah, I don't think there's a co-op program. So otherwise you'd have to be like working for a year. You'd be just like a new grad that quit and did their master's, right? Because that would just be where you're kind of designing your own program. But if you're going full time, the intention of a full time is that you're coming to stay. So that's part of the deal there. Hi, the jobs requirements mostly ask for the expertise of C and C++. So does it consider Java main graduates? Thanks. We don't do a lot of Java. I'm trying to think if there are parts of Cadence that do Java. I mean, in my division, it's all C++ all the time. And I think in most parts of Cadence, it's all C++ all the time, because we make high performance numerical software. And that software has to be able to run on the bare metal. And in the case of emulators, it has to interface with drivers and talk to the emulator. And that has to happen at the speed of as fast as we can run it. And so the JVM is a good VM, right? Java has gotten quite fast over the time, but Java's real strength is in like software security, as I see it. So it's not. I can't think of a specific spot where we use Java, but I would say if you I learned Java when I was in high school, right? So if you can learn Java, you can learn C++, but I would, your interviews will probably be in C++. So I would start gaining more C++ experience, because especially that's what you're going to be doing all day. And the languages are quite close, right? If you were on Python, then it would be harder to make a jump over to C++. I see a hand
Hi.
by,
So
yeah, go ahead.
yes, it's me. So I had a question kind of related to the same question. So I see job postings and sometimes I do not cover all the requirements on there. So for example, I know C, I know C++, but I won't be so good at Python, right? Or I won't have some hardware requirements. So in that case, what do you think is the minimum requirement I should be matching with before I apply for the job to be eligible for it in a way?
Definitely if it lists C++ and Python, and you know the more complicated language, which in this case is C++, I would apply if, if it just comes down to like C++ and Python and you know C++, because you can learn Python quite easily. And, I pick up Python on and off for odd jobs and that kind of thing. If you're interviewing for a hardware role, then you really do need to know your hardware. So stuff like system Verilog, stuff like how you would design a, asynchronous FIFO, stuff like, I guess stuff like in computer design, stuff like caching. I'm not sure if they ask those things of ASIC designers, but that's like a classic computer engineering question, caching, memory design, stuff like setup and hold time, all that kind of bread and butter stuff of ASIC design that you would get in your, I guess a junior to senior level course. That's the kind of stuff that we'd be looking for ASIC designers.
So just to be clear, so suppose the job description is asking for Python, C++, and I covered that, right?
Yeah.
But it asks for some of the FIFO stuff that I'm not familiar with at all. Would you think it would be a good option to apply to your company and be willing to learn hardware stuff on the job? Or is that not an option because it's too complicated to be learning on job?
Yeah. I would apply for a software role, right? Because it's not like everyone has the way a company ideally works is that everyone does what they're really good at and performs at their highest level to exceed customer expectations. And so at the end of the day, like I was kind of in your position. I'm interested in hardware too, but my forte isn't hardware. I'm a C++ guy, to my bones. So when you think about your day to day, it's, I would stick more to what you know, right? I would, unless you're doing an internship, if you're applying for an internship, then you can kind of lean out more. But if you're applying full time, then I would just stick to the subset of like, here's what I'm really good at, because you're going to be asked hard interview questions about what you're good at, and so you can really perform. And so, yeah, that's my answer. Is that I would drill down really hard on what you're good at. And if you're interested in hardware design, I would start taking some hardware classes now, if possible, or in your master's, if you're going to do a master's. That's what I did, is that I started learning more about circuit design in my master's. So if you're interested in exploring that area, definitely, that's the benefit of a class, is that you're able to go test something that you're not sure if you're good at. And if you get an A in it, then maybe you are good at it, and maybe you can do it in industry. So I would start down that path. I don't know if the recruiters have any other comment on that.
Yes,
So I'm going to pop in here to add that we've passed like the 2 o'clock mark for today's event. And we want to be able to respect the recruiters' availability for today's event as well as the students. I want to check in with Daniel, Brian, and Kira. What level of availability you have for the remainder of questions. Depending on your availability, we could add an additional, say, 5 minutes, but that's dependent on your availability for today.
Yeah, I have another 5 minutes. If you guys do.
Let's just take the last one that I see popped up, and then we'll close out. How about that?
Thank you very much. I appreciate your time.
Yeah. So I see Philip Nguyen asked a question. Hi, some job listings have Linux platform experience as a strong plus. Could you go into more detail on this? So maybe I can pull up the Workday thing. Maybe it's loading while I talk. Oh, okay. Yeah, so it's kind of the stuff that I mentioned before. So knowing your way around a command line, knowing the basics of SSH or how to use a shell or how to write bash scripts even can also be useful. I would say if you're interested in machine learning, stuff like how do you set up your own TensorFlow notebook, maybe some stuff about software security, like it's easy to make a Python notebook vulnerable to attackers, but generally it'll be behind a VPN, so you don't always have to worry about that. Other stuff with Linux platforms, I'm trying to think if there's anything else that I'd mention for this kind of role. It's more that you're comfortable, comfortable on the command line. That's how I would say it. Yeah, recruiters, you want to add anything else?
Is the most of your internship postings, are they more security dependent, or are they, as you before said, it's more C dependent with the computer software generation and program stuff?
The latter, yeah. Yeah. Yeah, I guess we're starting to get more into software security. In some ways, we have a partnership with Green Hills Software, but that's like a separate thing going on where it's definitely the latter. Yeah.
Thank you, Daniel. I think we'll need to wrap up this event for now. We are a bit over time for the event, but thank you very much for attending for today. Special thanks to Brian, Kira, David, and especially Daniel for your presentation. Thanks to all the students for attending today. As a reminder, if you want to just make a statement that I was here for today's info session, please check the check-in forms. We periodically were posting the check-in sheet in the chat window. As a reminder, we are also recording today's event. We'll be posting it later on the YouTube channel, either later this week or I would say early next week. If you subscribe to the YouTube channel, you'll be able to be notified when that video is up. So there's the URL in the chat for our YouTube page. I'm going to pull up again the check-in sheet. Because the Cadence check-in sheet does have a section for you to include your contact details for Cadence. That will be, yeah, I'm adding in the URL in the chat window here. There we go. You'll be able to include your contact details so that Cadence will know that you were here and you have your contact details provided for them. And that way you can have some additional contact if you have any questions that weren't immediately addressed from this call. But thank you again for attending, Daniel and team, and thank you all to the students for coming for today.